In section 4.5, we're going to see what we do when we're adding and subtracting fractions that don't have the same denominator, when the denominators start out different. So the first thing, we're going to review the least common multiple. So if we have the least common multiple of 35 and 10. Now this one I'm going to do with the method where I look at the biggest number, and that's 35, and 10 will not go into 35, so that won't work. And now 2 times 35 is 70. 10 will go into 70, so 70 is the least common multiple. It's the same thing when we're doing the adding fractions, but it's going to be called the least common denominator. So of 13 over 36 and 11 over 27. So the first thing I need to do, and the questions that you'll have, is just what is the least common denominator. So first, I'm going to look at 36. 27 will not go into 36. So I'm going to go 36 times 2, which equals 72. 27 will not go into 72. 36 times 3 equals 108. And 27 will go into 108 4 times. That part doesn't matter for these first questions, but our least common denominator then will be 108. Okay, then you might have one where it has 14 over 25, 13 over 35, and 7 over 15. And we need to see what the least common denominator is for these. So we're going to look at the biggest number here, and that's 35. And it only matters if one of these won't go into something, then that one won't work. So first off, 25 won't go into 35. Our next choice is 70. 25 won't go into 70. So our next one is 105. 25 won't go into 105. Next one is 140. 25 won't go into 140. Then 175. 25 will go into 175, but 15 won't. So the next one is 210. 25 won't go into that. Then 245. 25 won't go into that. 280. 25 won't go into that. 315. 25 won't go into that. 350. 25 will, but 15 won't. Now this is one where you have to go all the way down to 525 to get the least common denominator. So here's one where it's easier to figure it out using the factor trees. So we have 25, 35, and 15. And we're doing the prime factorization. So 2 won't go into 25, neither will 3. 5 will. It will go 5 times, and that's the prime number. 2 won't go into 35. 3 won't, but 5 will. It will go 7. That's also a prime number, so we're good there. And for 15, 2 won't go in. 3 will. 5 will, and that's a prime number. So now we're going to find our number here. So here, 3 only exists once. 7 only exists once. 5 is in all 3 of them, but here it's 2 times, so we have to use it both times. So we're going to have 5 times 5 times 7 times 5. 5 times 5 times 5 is 125 times 7, or 5, yes, is 525. Or, nope, this is a 3. 5 times 5 is 25 times 3 is 75 times 7. So that's how you can do just the least common denominators. Again, that's a 3. 5 times 5 times 7 times 3. So let's say now that we're going to add fractions. So say 5 over 12 plus 7 over 16. So we need to find the least common multiple, least common denominator of these two. It's going to be 48. 16 will go into 48 3 times. So we're going to multiply this fraction by 3 over 3. What we're doing is just multiplying it by 1, because 3 divided by 3 is 1. So we're just doing what we did in the previous section where we're finding equivalent fractions. 12 will go into 48 4 times, so we have to multiply this one by 4 over 4. So now we're going to have 4 times 5 is 20, 4 times 12 is 48, plus 7 times 3 is 21, over 16 times 3, which is 48. Now we have common denominators, so we just keep that denominator, which is 48, and 20 plus 21 is 41. Next, let's say we have 13 over 28 plus 1 over 8. Okay, so 8 won't go into 28, so 2 times 28 is 56, and 8 will go into 56. So this one is going to be multiplied by 2 over 2, and 8 will go into 56 7 times, so this is 7 over 7. So now 2 times 13 is 26 over 56, plus 1 times 7 is 7 over 56. We keep the 56 as our answer. 26 plus 7 is 33, and there's nothing that we can simplify here. Next, let's do one that's a little bit easier, and I'm going to show you another way that you could do it. So let's say we have 1 over 4 plus 1 over 6. 4 won't go into 6. 6 times 2 is 12, and 4 will go into 12, but let's say that you don't want to spend the time finding the least common multiple and the least common denominator. You can always use just a common denominator. And a common denominator that will always work is when you multiply the two numbers to each other. So 4 times 6 is 24. That one will work. So 4 will go into 24 6 times. So multiply that by 6 over 6. Multiply this one by 4 over 4. If you notice, what I'm doing is multiplying the first fraction by the second one's denominator over itself, and the second fraction by the first denominator over itself. Now when I do this, I'm going to have 6 over 24 plus 4 over 24. Add those and get 10 over 24. But now I do need to simplify, divide both by 2, and get 5 over 12. Which, if I did 1 over 4 plus 1 over 6, multiplied this by 3 over 3, and 2 over 2 to get 12, I would have 3 over 12 plus 2 over 12, which does equal 5 over 12. So you can find the least common denominator, or just multiply all the denominators to each other and use that as your common denominator, but you will probably have to, you most likely will have to simplify. Sometimes, however, like 3 and 4, if you had 1/3 plus 1/4, the common denominator is 12, or 3 times 4. So let's do a subtraction. Let's say we have 17 over 20 minus 3 over 8. Alright, so 8 won't go into 20, but 20 times 2 is 40, and 8 will go into 40. So this is going to be 2 over 2. This will be 5 over 5. 2 times 17 is 34 over 40, minus 3 times 5 is 15 over 40. We keep the 40, and 34 minus 15 is 19. So 19 over 40. Next, let's do one that has some negatives. So let's say we have negative 3 over 4 minus a negative 9 over 14. So we're going to do this just like we did before with the whole numbers, but first we're going to change everything to, Well, first let's change this to, we have a minus, so that becomes a plus. So let's do that first. Negative 3 over 4 plus 9 over 14. Let's just break it up into a bunch of small steps. Now, 4 won't go into 14. 2 times 14 is 28, and 4 will go into that 7 times. So we're going to multiply this one by 2 over 2, and this one by 7 over 7. So now we have 7 times negative 3, which is negative 21 over 28, plus 9 times 2, which is 18, and it's over 28. So now we're going to keep the 28. We have a negative 21 plus 18, which is negative 3, and that will be our final answer. So the last things that you'll do in this section are comparing fractions to each other. So say we have 1/2 and 1/4, and we need to know which one is bigger. The easiest way to do this would be to change them into decimals. So divide them out and go 2, well, just go 1 divided by 2, and it's going to be 0.5. 1 divided by 4 is 0.25. 0.5, the 5 part is bigger than the 2, so it's greater than. And the way you do that is just 2 into 1. 2 won't go into 1, so you have to put a 0.0. 2 will go into 10 5 times, and remainder. And 4 will go into 1. Won't go into 1, so we have to put 0.0. 4 will go into 10 2 times. 2 times 4 is 8. 10 times 8, 10 minus 8 is 2. Put another 0. Bring it down. 4 will go into 20 5 times. So that's the easiest way to do these. The next one I'll do is 5 over 8 and 3 over 4. So the first thing I'm going to do is turn these into decimals. 8 will go into 5, and we have to put, I know I'm going to have 3 zeros here, so 5 will go into, 8 will go into 50 6 times. 6 times 8 is 48. Have a 2, 0, it'll go into 22 times. 2 times 8 is 16. 20 minus 16 is 4. Bring down the 0. 8 will go into 40 5 times. 5 times 4, 8 is 40, and it's 0. So 0.625, and then 3/4. 4 will go into 30 7 times. 7 times 4 is 28, with a 2 remainder. Now here, notice that I have a 0.6 and a 0.7. I don't need to keep going, even though I could, because I know that 0.7 is bigger than 0.6, so I know that the answer here is going to be less than. And this is 0.7, and it doesn't matter what the rest of them are. So as soon as you find where they, it's definitely less than or greater than, you can actually stop there. And that is it for section 4.5.